Okay, students, we're going to do the exercise on basic univariate measures. There are two parts to this exercise, and I'm going to make two separate videos, one for each part. And in part one, you're going to have to enter data directly into the Jamovi program in the same way you would in an Excel file, in any spreadsheet. So we're going to start there, and then we'll take a look at how the data is entered. We will measure it. We'll look at possible outliers and ways to control for them or eliminate them. So here we are in our Jamovi worksheet, and we're going to enter the data. And the data again represents the ages of 12 community college students enrolled in a statistics course. And you'll notice that the range is pretty great. Let's skip to one. And again, we will enter this data in the same way we would if we were entering data into any of the spreadsheets, like Excel. So here we are. We have our data entered, and if you look across the top, we just used we kept the default name of the ABC that comes up every time you open a Jamovi file if you're going to enter data. And the way we would change the variable name if we wanted would be to double-click, and it would open us into the editor. We could change the name from A, but right now we'll leave it as A. But what we do need to do is change it from a nominal variable to a continuous variable, as the variable age is above the ordinal. And so, again, I went over this last time, but in the nominal we have categories that can't be ranked. In the ordinal we have categories that can be ranked. And then continuous is representing either interval or ratio data, where there's an equal distance between every measure, and with ratio we have a meaningful zero. Okay, and then we'll give the variable a name, and that name will be student ages. So that is our variable name or description. And if it was a categorical variable, we could give it the names for every category, like male, female. So let's go back to our data and look at that. Oh, we'll close it here. And now we should be able to see. And you'll notice that now the A has a little ruler for the icon, and the other two have the bubbles that represent categorical data, nominal categorical data. Okay, so let's measure these variables. And we'll go to exploration, descriptives. And in our descriptives, we will identify the variable that we want to measure, and that variable is A. And as a dynamic program, as soon as we identify the variable we want to measure,
you'll notice that we get a set of values that are measured immediately. But these are the defaults, and we want others. So we'll go here to our statistics, and then we'll select the ones that we actually want. So we don't need the cut for the distribution into any equal parts. We do need the number of cases, the missing values if there are any. We want the mean, median, the mode. We don't need the sum. We do want standard deviation, variance, range, interquartile range. We'll get that in two ways, one with our box plot, and the other when we look at the 25th and 50th percentiles. We'll get the measure of the distribution shape, which will be skewness and kurtosis, which tells us how peaky the distribution is. We don't need the Shapiro-Wilks. We don't need standard error right now. We do want plots. So let's take a look at the plots that we want. We'll get the histogram, we'll get the box plot. We don't want a bar chart or a bar plot because that is for categorical or discrete data. We will take the QQ. And let's take a look at what we got. Sometimes you need to go back to data, and then that allows you to close and look at the output in a window of its own. So here we have the number of cases, no missing cases. We have a mean of 26.8 and a median of 23.5. The mode, the number that appears most often, is 24. The standard deviation is 14. And interquartile range, the gap between the 25th and the 75th percentile, is 2.5. The range is 55. And we can look at these others. But this is our view of the data. You can see that our 71-year-old definitely skews the data out. It distorts it. And on our box plot, you can see that that person is an extreme outlier. And that person is definitely distorting our data. And in our QQ plot, you can see again how much of a distortion it is. Now, let's go back. Let's take a look at the data without the outlier. And the way we can do that is we go here to our filter, we'll highlight that column, and go to our filter, and we'll say that we want data where the variable A is less than 40. And then we'll go back. And now you can see that we have excluded the 71-year-old. Now let's go and take a look at our data again. And you can see that now the mean has dropped from 26 down to 22.7. And so that tells you how much that outlier was affecting the mean. That one case made a difference of almost 5 points. The median was not affected. It's the same. It stayed the same. The mode stayed the same. Everything, now the standard deviation came way down. I think it was 16. if we wanted to look at how that affects it, we could either activate or deactivate the filter. And you can see the standard deviation changed from, let me see if I can get this. The standard deviation changed from 14 down to 2. So I'm going to go back and put our filter on. So here you can see that the standard deviation is now, get the screen right. Standard deviation is now 2. It came down from 14. What you can see is that the histogram is much more meaningful now. Let's see if I can get this. And the box plot. We still have the outlier down here at 16, but that is a lot less of it, makes a lot less of an impact. Now we can take that one out if we thought that it would make the data more meaningful. We can see that in the QQ plot is still considered an outlier that is starting the data. So here we are. These are our measures, and these are the measures that you need to interpret for this assignment. And you can play around with it and determine whether or not that 16-year-old person was enough of an outlier that is worthwhile to remove and explain that in your write-up, or whether that person is important enough to leave in the data.